All right, welcome back, everyone. In the last section of this chapter, in chapter 6, we're going to talk about how to determine if data are approximately normal or approximately symmetric, with the idea being that we need symmetric data in order to do a lot of the things that we're going to do moving forward in the next chapters upcoming. And so we want to be able to recognize that the data is symmetric in that way. And so in this section, I'm going to show you a brief little checklist here in just a second. Right, we're just going to discuss some methods to determine if data can be considered approximately normal. I'm going to show you this checklist. We're going to talk about it for just a second, and then I'm going to show you some examples in Excel where we kind of use this using the data from some of my class surveys. And then from this, you can use this to complete your assignment this week, along with the other MyLabs assignments in the other chapters. If you have any questions about this, let me know. So this checklist, but just so you all know, was made by me. I just kind of made this as a way for you guys to figure out how to step-by-step go through some steps that I go through generally when I am trying to determine if data would be considered normal, or if we can consider it normal. Okay, the first part is really simple, and it's just something that you have to recognize. If the data are known to be normally distributed in the population, so something like height, we know that height is normally distributed with everybody being around the average, and being less people further away from the average. Then if you take a sample of height, sample of 30 people, 50 people, right, you can assume that that sample, generally it's greater than 30. You can assume that that sample is essentially normally distributed because we already know that height is normally distributed. Okay? It's when we have samples where we're unsure in the population whether the value is normally distributed, where we have to make some different considerations, right? So the first thing that I always do, and this is something I suggested a few chapters ago, but the first thing that I always do is compare the mean and the median. Okay, and we want to look at whether these two are essentially real world equal. Okay, and what I mean by that is there a real world difference between what the mean value is and what the median value is? Right, so a difference of 0.3 in height might not really mean anything. Okay, and so we'll talk about what a real world difference would be if we were to look at it in terms of the some actual data. Okay, if they appear to be equal, right? So if yes, right, then they might be symmetric, right? If the mean and median are pretty close to equal, or as I like to say, real world equal, right? Then they're probably symmetric. So you can generate a histogram, okay? Choose a bin width that's about 1/2 the standard deviation, okay? And then look at it. Does it look like a bell curve? Does it look like it's symmetrically distributed, right? Okay, if so, then yes, right? If not, then it still looks skewed and it may not be normally distributed. Okay, if if there are no, if you then compare the two and they're not real world equal, okay, then you might have an outlier there, right? That's skewing the mean. Okay, so your first step there would be to make a box plot. Okay, determine if there are outliers. Okay, see if the box plot shows you if there are any outliers, and then you can use the shape of the box plot, the length of the whiskers, to figure out the distribution. Does it still kind of look symmetrically distributed, right? Are the whiskers about the same length? Is the box about the same on both sides? Okay, or is there still some skew due to an outlier? Okay? If there's a skew, right, or if there's some outliers or something like that, then you can't consider it to be normally distributed. Okay, but if there's not a skew, right, if it still kind of looks normally distributed, right, even though the mean and median aren't what you consider real world equal, okay, then you essentially say no and you go back to the previous step. Okay, you would then make a histogram after that and go and make the standard deviation, the bin width about 1/2 the standard deviation, and then use the distribution, look if it's symmetric, and then make that choice there. And so let me pause here for just a moment, and I know you guys might hear my kid in the background as well, but I'm going to pause here for just a moment, switch over to Excel, and then we'll kind of go through this checklist, and I'll show you how to do this with some real examples. All right, folks, so here you should be able to see this is data from the question that was how many TVs do you have in your home? Okay, and so there's some 50 odd data points here, but I've calculated the mean and the median and the standard deviation just so that we have it. You can review how to do that in some previous assignments if you need. But if we look at the mean and the median, right, 3.1 and 3, if I think about that, I would say that that's probably about equal, right? So I think that the mean number of TVs and the median number of TVs being, the mean being about 3.1, that's about 3 TVs, right? So they're about equal to each other. And so what I would probably do here is then I would make a histogram. Okay, that would be make a histogram with a bin width about half the standard deviation. Okay, and so what we're going to do is we're going to first highlight the data, go to insert, charts, we want to find a histogram. Okay, we're going to hit OK. Now that looks a little skewed to me from here, but let's see. Bear with me 1 second. You should be able to see these options, I hope, as they pop up. We want to adjust the bin width. Okay, this is under horizontal axis. And we want to you click on these little squares there, go to bin width. Okay, now it adjusts it for 1.7, about half the standard deviation. And because these are whole numbers, right, let's just do it as 1. Okay, we'll make it as a bin width of 1. Now we can close this, and now we can see the shape of the distribution. Okay, well now it is kind of real world equal, but we can see that it is skewed a bit from where the mean and the median would be, right? And so that mean is pulled a little bit towards those higher values because these are probably outliers. And so in this case, if this were a real research project, we might be able to consider this as still being approximately normal. We probably would want a larger data set. Okay, but in general, that question is probably not going to be normally distributed overall, unless the mean were to fall somewhere higher up, right? Because you can't have less than 0 TVs. And so most people are probably going to be clustered down towards the bottom anyway. And so, these probably aren't normally distributed. I would not try to use this to do what we'll do in the next section and in the next chapters. I wouldn't really. I would, and you'll see that the TV's example won't really show back up many more times from here. Let's look at another example in terms of age. Okay, so a very similar thing. Here we have, these are just ages of students. We have the mean, the median, and the standard deviation. Here, the mean of nearly 36 and the median of 34, that does look to me to be very real world different. Okay, a couple of years, you could tell the difference between that. Okay, and so rather than a histogram this time, I would make a box plot. Right, so we're going to go to insert, and then go to charts, box and whisker. Okay, and now we can adjust this just a little bit. Now we want the vertical axis because we want to change this one. And we'll just start the minimum since we're talking about college students here. And just to give a little space, we'll start the minimum at 15. And we'll go to the maximum of, let's just say it's 60. And now if we look at this box plot, right, you can see that the mean is a little bit greater than the median. Okay, but you can definitely see that this whisker is longer than this one. right? And so there's a possible outlier here. Okay, but it definitely looks like there's a skew to the data, right? There's probably something over here skewing the data. If we were to make this into a histogram, we would expect to see then that outlier or that skew to the distribution. Okay, now again, we have to adjust this to about half the standard deviation. Notice it shows a standard bin width of about 10. Let's use about 5. Okay. Though it's a little tougher to see, you can see a little bit of a skew here. There's a lot of people that are younger in general, and then there's quite a few over here as well. Right? So this doesn't appear to be normally distributed at all. And once again, age, not really a useful thing when you're talking about some of the things that we'll talk about later, right? We can't really ask a question about the average age of a college student because everybody could be different when they go to college. Right? And so there's no way to talk about things like that, like a mean of the students. We could find the average, right? But that just gives me the average of the class. And that changes all the time. And that's what you would expect. So let's look then at height. Okay, height has a mean of 66.7 and a median of 67. Those, in my mind, in terms of height, if you were looking at someone who is 66.7 inches tall and 67 inches tall, you're probably not going to be able to tell the difference between them. Right? So I would call those real world equal. So then we can then take our data and we want to make a histogram. Highlight data, insert, and go to histogram, hit OK. And now, again, we want to adjust the bin width so that it's about half the standard deviation. If that is 3.5, we'll call it about 1. We can do 1.5 or 1.75. Let's do 1.75 because we're talking about height. And notice that even though there's a lot, there's not so many here. Now there's quite a few here. And you can really see that this looks a bit less skewed than some of the other data. And even with a smaller sample. And so I would say, yes, this would be normally distributed. And that's why you'll see this data and height data in a lot of the examples and other types of examples. Okay, and so you can use this checklist and these different, use either a box plot or a histogram to essentially assess whether the data are approximately normally distributed, whether they're symmetric. And then you can use that, if they are symmetric, you can use that data for what we're going to do in the next couple of sections. Let me know if you have any questions about these different types of charts in Excel or what you saw here in Excel, or how to answer the questions on the assignment this week. But your Excel assignment this week focuses on determining whether these some data sets are normal. So use this video to help you with that. In the next sections, we'll talk about the next chapters, which will carry on some of these general ideas.